Well, you have another example going through normal forms, and it's a fairly standard and should be common to everyone area example. It's an order example here where you're representing a company that has to maintain orders for a set of items that you're going to ship out to folks. Now, there's a couple of assumptions that come into any database. One, we're going to assume there's only one name or address per customer, so that the customer would be Paul Bolstead at the University of Minnesota and not the University of Minnesota, because there can be multiple people that would order from the University of Minnesota. And there's only one entry for each item in any order. That is, the software or the order system would consolidate. If a person asked for 4 blue frames early in the order process, then in that same order asked for 4 more blue frames, it would sum that up to 8 blue frames. So there wouldn't be 2 of the same item in any single order. So we are putting these on to make sure that our normal form system makes sense. So we have the typical things in an order. We have who we're going to ship the order to, who's the person doing the order, what's their address, and then items with a description and a price, and then the number of items, and then the total cost, that is the number times the unit price. So there's stuff associated with the order, stuff associated with the person, and stuff associated with the item. And so you can see we probably will have at least 3 kinds of tables here in this system when we finally get to our normal forms, because the organic sets are the person, the order, and the item. And then we'll need a way to link them. Now, when I first put together my system, if I'm just using a spreadsheet, I might put together a large flat file like this with all the issues that it might have, right? So here's my spreadsheet. I have an invoice. It's number 125, and there's the date and a customer number. And then I have, again, remember the repeat columns here. So I'll have the item and its ID and the number and the description. And then I'll do that again. And there's the item ID. It's the item description, the number of those items, the price. And so I have, again, some orders that have many items, some orders that have few, and I get this empty space and this redundant column stuff, and the stuff all mixed up. So the usual flat file issues. If you want to find out how many red frames were ordered in 2002, I'd have to go through and find all those orders that were in 2002, and then I would have to look at all the columns, and sometimes I'd be searching empty columns to find red frames and the number. And then what's the total number of 3-inch red or blue frames sold in California? So I have to look at these multiple column sorts. And customer information, so I have to look basically in this one column. Well, to get it to first normal forms, remember we got to get rid of those repeat columns. And we do that by copying the other information that's not something to do with the item, right? Because here we have the item and all the information goes with it for our repeat column. So there's the item ID, the description, the quantity, the price. The item ID, the description, the quantity, the price. And so for each of Order 125's versions or instances of these items, I'm going to make a new row. In this case, there were 4 items for Order 125, this invoice 125. And so there's all the stuff that I copy, and then there's the items that's unique to that particular item in the order. There were 2 items in 126, so it gets 2 rows, right? So we're copying these first columns, and then we're just reducing that redundant row or set of rows down to 1 row, right? Again, we're kind of going backwards to go forward. Now we have this problem of these items that are basically repeat values for that particular invoice. But remember, we go to first normal forms to second normal forms, and we get rid of that. We make everything in tables dependent on a key, and we split the tables up so that everything is function dependent on a key in the table. So we have an orders table and an item table. Those are the 2 main things that really distinguish these. And remember, we identified we had sort of the orders, the items, and the customers. And the customer table will come out when we go to third normal form. So right now we're going to say, well, there's no one column for a primary key, but then there's these 2, the orders, items together will make one table, and then each of those, the order table and the item table, will get another table. And so this is typically the way it works when you split it. You have the repeat column thing, and then the initial thing you thought would be working as a key in your flat file, and those two together form the table that has a multi-column or concatenated key, and that is an important table for connecting the other disparate tables. So I split those two out. So I have basically the orders with all the stuff that's dependent on the order, and the items with all the stuff that's dependent on the item. Those are each going to be primary keys in their own table. And there's going to be a table that's a combination of those two to connect those tables together. So we have this order item combination, a concatenated key in one table, a table for the items, and a table for the order. So we split the stuff up. All right. Again, second normal form, every non-key item is function dependent on the key, and it's either directly or through a transitive functional dependency. So right now we're not going to worry about this transitive functional dependency. We're just going to say we have the order and the date and the customer for that order and the customer name and the customer address. I know the order ID in my table. I know all that stuff, right? Because remember, for this order ID, there's a particular invoice, and you get given the invoice or the ID number, and you write down, okay, the one person that's ordering it, and the customer number associated with that one person, and the address information for that one person ordering it. So all that stuff, customer address, the customer ID, and the order date, are associated with the order. And then there's the items that they're ordering. So there's an item description, an item quantity, and item type that all goes with the item ID, right? And so I basically have this order item, right? And these two together, the custom sort of ID, customer ID, and the item ID, right? So if I basically break the table up by projecting over the primary key, it's a fancy word for subsetting, and making things dependent only on them. So what columns are dependent on this primary key, right? So our first normal form table are the order, the item, and the quantity, right? In each order item pair, we have a different quantity. In order to know the quantity for the order item together, I have to have them both, right? The order and the item, to get the quantity. So that's the stuff that is associated with that specific order and item. I might have a different order in the same item, 563, and then I have a different quantity. But if I know these two, I know this for that order item combination, right? And so then we also subset by those functional dependencies. If I know the order, again, there's all that stuff. And if I know the item, there's all that stuff. And so I split the tables up. Again, this combining table, and then the item table and the order table. So you can walk through the verbiage here, projecting over the primary key plus variables dependent only on the primary key. And once you get those concepts fixed, you get that idea down. But really what you're doing, again, is looking back and saying, what are the organic groupings? And those are the orders and the items. And then the things we need to connect those to, the order item pairs. And the item quantity is dependent on that order item pair. So we have to put that in that too. So we identify those functional dependencies, which we kind of knew from the beginning, and we split up by the items and the orders, and then the IDs. Now the thing about the ID, order ID here, is that we have customer ID, which depends on the order ID. Right? We only have one customer. Remember, we fixed that for the order. But then there's all this stuff that's dependent on the customer ID. So we have this transitive functional dependencies. There's no transitive functional dependencies here, right? But in this case, there is a fractional transitive functional dependency. Now, one of the reasons there is maybe no transitive functional dependencies in these others is because the items are set: item ID, item description, item price. But here we have sort of the order and then the customer, and you can see, well, I have the order and order date and the customer ID, but really once I know the customer, I know all this stuff. Remember, we required the customer only have one address. And so this thing has a transitive functional dependency, this table. So we have to split this table up, right? You split this table up by removing this transitive functional dependency and getting another table that has the customer ID and the customer name and all that stuff together. And so that table gets split up. Now you can see the advantage of this because we only have then for the customer ID one entry in the table. For each customer ID, there's an entry. If a customer changes their address, I only have to go to this one table in this one location and change it. If I want to find out who's the customer associated with an order or their address, I can link this table to this table by the customer ID, right? But I have to do that first through the order ID. So I have to go this table to this table, then this table to this table. So I get the information by linking through multiple tables. If I want information on the item, like its name, from the item ID in the order, well, then I have to link this table to this table. Now, the great thing about this is no matter how many orders I add, you can see that if I add orders, the only tables that I'm going to have to expand are these two tables. Each order is, I'm going to get an order ID, so I generate a new one. It's going to be another row for each order here. And then there's going to be the order ID, the item, and the item quantity here. So this table grows with each order by however many items get ordered. This table grows just by one with each new order. These things get left alone. If I change the inventory, I decide I want to change the name. Instead of calling this as a blue freen, it's actually a blue-green freen. I'm going to have to go into this one table and change that. In these other combinations, and especially in my flat file at the start, I would have had to go in and find all the instances of those to keep it consistent and change the name looking through multiple columns. Same thing if there were multiple orders from a person and they changed their address, well, I'd have to go through and find every order that had that customer name and change it in multiple locations. And that's really no fun and prone to errors. Here I just have one table where I go and change it. And so that's one of the strengths of these normal forms is it isolates the data. And if I want various pieces, I just have to join the data back. Now, this is a small data set with just a few parts, 4 tables. But if I have literally tens to hundreds of tables like the census data, different people want different pieces of data, and so I only link in the data I want instead of having this huge unwieldy data set. So remember, first to go to first normal forms, we reorganize the table to remove the repeat column. So from that flat file to that sort of redundant row. Identify a primary key. Now in our case, it was a key where everything was dependent on that. And in my first normal form table, there were really 3 things that went in that. There was the order and the item, and then the number of items ordered was dependent on that. And I could pull that out to identify the second normal form tables that are only partially dependent on a primary key. So what I'm doing is I'm splitting that table up. I have that original item order table, and then the items table and the orders table. And so basically I have split into second normal form. And to go to third normal form, I noticed in that orders table there was the redundant information from the folks' names, or their IDs really, and then all the other information associated with them. Their name, their home address, their state, their zip code. And so I split that table to get it to third normal form where everything was dependent. I had a person table, an order table, a item table, and then this order item quantity table that keeps track of the quantity for a particular order. So again, a lot of power in understanding why these things are structured this way. You'll run into them if you work in GIS in a large organization, or if you have large data, you'll need to organize them yourself this way. So I hope this helps.